Let us continue hydrogen and its compounds, in which we will take nascent hydrogen. We are considering nascent hydrogen. Nascent hydrogen means newborn hydrogen. Nascent hydrogen means newborn hydrogen, we can say. For this, we will see the example. Now we will take a potassium permanganate. We will take, it is violet color. It is taken in acidic medium. Acidic medium means sulfuric acid is mixed. Then hydrogen gas is passed. Now potassium permanganate is not going for any reaction. No reaction takes place here. Now we will take a same potassium permanganate. We will take acidic medium. We will take. We will add zinc pieces. Now we are adding a zinc pieces. We are adding. Now what is the product? We will see. It is violet color. This violet color becomes a very light pink color. This violet color becomes a light pink color. This light pink color is responsible for Mn2 plus. This light pink color is responsible for what, in the sense Mn2 plus, we can say. That means acidified potassium permanganate violet color disappears here. Disappears in the sense this Mn plus 7 is converting into Mn plus 2. This Mn plus 7 is converted into Mn plus 2. So what is the reason? What reaction takes place here? That we will see. Now in this place, this zinc is undergoing oxidation to give zinc ion. These electrons are taken by this H plus. This H plus takes this electron and becomes a hydrogen. This hydrogen converts permanganate into Mn2 plus, while this hydrogen becomes H plus. That means hydrogen is donating electron and becomes H plus. That electron is taken by Mn plus 7 and becomes Mn plus 2. Okay, so here this hydrogen is produced in the chemical reaction. This H is produced during the chemical reaction and disappears in the chemical reaction. It is producing and immediately it is disappearing in the chemical reaction, isn't it? Because we are taking H plus, that is becoming H. That H immediately becomes H plus, isn't it? Therefore, this hydrogen is a newly born hydrogen. This hydrogen is called a nascent hydrogen. Due to nascent hydrogen, permanganate undergoes a reduction, whereas here nascent hydrogen is not there. Therefore, permanganate is not undergoing reduction. Sorry. So in this place, there is no nascent hydrogen. So permanganate is not undergoing reduction. In this place, nascent hydrogen is there. Therefore, permanganate undergoes reduction. So nascent hydrogen and molecular hydrogen. It is nascent hydrogen. It is molecular hydrogen. Which is more reactive? Nascent hydrogen is more reactive. Molecular hydrogen is less reactive. So next, we will take another example for this nascent hydrogen. Now we will take chlorate, ClO3 minus chlorate we will take. This we will take in acidic medium. To this let us add zinc. What will happen? That we will see. What is a product? That we will see. Now this zinc is undergoing oxidation and gives electrons. This acidic medium H plus takes this electron and becomes a nascent hydrogen. This nascent hydrogen converts chlorate. This nascent hydrogen converts chlorate into chloride and nascent hydrogen becomes H plus. In the previous case, we will see in this place. Here, this due to this zinc, H plus is converting into nascent hydrogen. This nascent hydrogen converts permanganate into Mn2 plus. This nascent hydrogen is from where? We have taken acidic medium H plus. That H plus is converting into nascent hydrogen. Immediately that is becoming H plus. That means zinc electron is carried from this electron is carried from zinc to manganese. That is the work done by this H plus. So now we will see here. Zinc is becoming Zn2 plus and 2 electrons. Like previous case, this H plus takes electron. This H plus takes electron and gives to this chlorine. Here chlorine is in +5 oxidation number. Then this +5 becomes -1. This H again becomes H plus. So here chlorate is converted into chloride. Chlorate is converted into chloride because of nascent hydrogen, we can say. So here nascent hydrogen converts chlorate into chloride. Okay. Next we are taking chlorate, we are taking sodium amalgam and water. Sodium amalgam and water. Here what is the reaction that we will see. In this case, sodium is converting into Na plus and electron. This now here this water contains hydrogen. This electron is taken by this hydrogen. This bond is shifting as lone pair to oxygen. This hydrogen becomes a nascent hydrogen. This nascent hydrogen is attacking this chlorate. Now there is no reaction. Chlorate is not undergoing reduction here. Chlorate is not converting into chloride. But here chlorate is converting into chloride. Here chlorate is converting into chloride because of nascent hydrogen. Here chlorate is not converting into chloride though nascent hydrogen is present. That means why here reaction takes place, here reaction not taking place. That means reactivity of nascent hydrogen is different. Reactivity of nascent hydrogen is different. Here reactivity is more, therefore reaction is taking place. Here reactivity is less, therefore reaction is not taking place. And another thing, for whatever the reaction is there, that will have certain path. That means the reaction will follow like this path. Now we can say it is the average energy of reactants. It is average energy of products. This we can call it as threshold energy. Threshold energy. This we will say activation energy. This we will call it as activation energy. If the reactants gain activation energy, then it will cross the energy barrier and it will give product. Here reaction takes place means reactants cross the activation energy barrier. Here reaction is not taking place. That means reactants is not crossing the activation energy barrier. That means in this case, average energy of reactants may be like this. In this case, average energy of reactants are like this. Therefore, which is having lower activation energy, you see. For which case activation energy is low? For this case we can say activation energy is low, therefore reaction is possible. This case activation energy is high, therefore reaction is not possible. Why activation energy is changed? Here threshold energy equal, no? Threshold energy means minimum energy should be possessed by the reactants to give products. Threshold energy is same for both, but reactants are different, therefore threshold energy difference will be there. Yes, because reactants are sodium is there, here zinc is there, therefore threshold energy difference will be there. But anyhow, here reaction takes place, here reaction not taking place means here activation energy will be low, here activation energy will be high. That's what we can say. Sir, so chlorate is not converting into chloride in the presence of sodium amalgam and water. Chlorate converts to chloride in the acidic medium by zinc, because here nascent hydrogen is having high reactivity, here nascent hydrogen is having low reactivity. That's it. Sir, why nascent hydrogen? Here nascent hydrogen means H, here also H. Then why they have different reactivity? Nascent hydrogen means what? H. They are having different reactivity means they behave in some different manner. So that is explained in what way. You see that here we are taking solution. That means chlorate, acidic medium, zinc metal, these and all we are adding. Now what is producing in the sense nascent hydrogen is produced in the form of bubbles. Okay, nascent hydrogen is produced in the form of what means bubbles. Inside this bubble, there is a many number of nascent hydrogen atoms will be there. That is exerting pressure. Depending on the pressure, reactivity will be there. Here reactivity is more in the sense here pressure is more. Here reactivity is less in the sense here pressure is less. Therefore, nascent hydrogen is produced in the form of minute bubbles having certain pressure. Based on the pressure, based on the magnitude of pressure here, reactivity will be there. Here, the minute bubbles is such that the pressure is high, therefore reactivity is high. Here, minute bubbles is such that the pressure is less, therefore reactivity is less here. Okay, so nascent hydrogen from different sources will have different reactivity. Here, nascent hydrogen is from zinc acidic medium. Here, nascent hydrogen is from sodium amalgam and water. Reactivity of nascent hydrogen in these two cases is different because source of nascent hydrogen is different. Therefore, if source of nascent hydrogen is different, reactivity of nascent hydrogen also will be different. Sir, next point we will see regarding this nascent hydrogen. Now we will take NO2 minus nitrite. We are taking nitrite. To this, what we are adding in the sense zinc we are adding in basic medium. Zinc we are adding in basic medium. Now this zinc is converting into zincate ZnO2 2 minus. This formula, remember it, it is oxoanion. Zinc is converting into zincate. Nitrite is converting into ammonia. Nitrite is converting into what in the sense ammonia. Nitrite is converting into ammonia. Sir, now we will take another reducing agent, that is a sodium amalgam in water will take. Sodium amalgam in water will take. Here sodium is converting into, this sodium is converting into Na plus, that we know. This nitrite is converting into hyponitrite. 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 Nitrite is converting into hyponitrite. That means here nitrite. In nitrite, what is the oxidation number of nitrogen? That we will see. +3. In ammonia, nitrogen is -3. In hyponitrite, nitrogen is +1. That means nitrite on reduction gives ammonia. Nitrite on reduction gives hyponitrite. Now see, reactant nitrite is giving different products. In this case, nitrite is reducing to give ammonia. In this case, nitrite is reducing to give hyponitrite. That means here nascent hydrogen, the nascent hydrogen reactivity is such that the +3 is converting into +1. Here nascent hydrogen reactivity is such that +3 is converting into -3. So if the nascent hydrogen is from different sources, then we are getting different products. Different products we are getting. Okay. So nascent hydrogen from different sources lead the reaction towards different products. Okay. This is about nascent hydrogen. So, next we will see about active hydrogen. We are seeing about active hydrogen. Let us take molecular hydrogen. We are taking molecular hydrogen. Let us give silent electric discharge. Silent electric discharge. Silent electric discharge. Ordinary temperature we will provide. We are providing ordinary temperature and pressure is 0.5 millimeter pressure. This hydrogen gas, molecular hydrogen H2 becomes active hydrogen. The name itself says it has high reactivity. Okay, that means so far we have discussed atomic hydrogen, nascent hydrogen, active hydrogen. Atomic hydrogen means molecular hydrogen on thermal decomposition gives atomic hydrogen. Nascent hydrogen means during chemical reaction it is produced, immediately it is disappearing. Active hydrogen means molecular hydrogen is subjected to silent electric discharge under low pressure and at not ordinary temperature gives active hydrogen. Okay, sir. Next we will see preparation of hydrogen. in what method we will prepare hydrogen, we'll see. Okay, so now preparation of hydrogen. Certain metals, some metals with cold water, gives hydrogen gas. So which metals with cold water gives hydrogen gas, that we'll see. Which metals in the sense? One is alkali metals. Alkali metals, that is lithium, sodium, potassium, rubidium, cesium, alkali metals. Then alkaline earth metals, calcium, strontium, barium, alkaline earth metals. So alkali metals, lithium, sodium, potassium, rubidium, cesium. Then alkaline earth metals, calcium, strontium, barium. These metals on adding into cold water gives hydrogen gas. Okay, now we'll take sodium. Sodium is added into water means we will get sodium hydroxide and hydrogen gas. Here sodium is converting into Na plus by losing electron. This electron is taken by H plus of water and becomes hydrogen gas. Okay, so water will write like this. So electron is attacking this bond is migrating, this H becomes hydrogen gas. It becomes OH minus and Na plus becomes NaOH. So alkali metals and alkaline earth metals, calcium, strontium, barium, with cold water gives hydrogen gas. Okay. How to store alkali metals? Alkali metals is stored in kerosene. Sodium, potassium, rubidium, cesium always placed in kerosene only. Why? Because these alkali metals should not be exposed to atmospheric air. If it is exposed, immediately it will go for chemical reaction. Therefore, because alkali metals are highly reactive, therefore alkali metals we have to store in kerosene only. In that lithium we cannot store in kerosene because it will float. Therefore, lithium metal is placed in paraffin wax. Lithium metal is placed in paraffin wax. Okay, so why sodium is placed in kerosene? Because it will react with atmospheric air. Therefore, it is placed in the kerosene cell. So alkali metals and alkaline earth metals, calcium, strontium, barium, on reaction with cold water liberates hydrogen gas. Next, preparation of hydrogen we'll see. We'll take metal, we'll take boiling water, otherwise steam we will take. Boiling water, otherwise steam. What we are getting in the sense hydrogen gas we are taking. We are taking metal that is treated with boiling water or steam. What we are getting means hydrogen gas we are getting. Set. How this reaction take? What is the metal we have to take? That we'll see. Metal is magnesium, zinc, aluminum. So aluminum with steam or boiling water gives what in the sense aluminum oxide and hydrogen gas. Here aluminum becomes Al3 plus by losing 3 electrons. Water we can write like this. So what happens means electron is attacking this. This is shifting. This hydrogen losing the bond, gaining the electron here and becomes hydrogen gas. So magnesium, zinc, aluminum with boiling water or steam liberates hydrogen gas, we can say. Next, some metals react with the dilute acids, that is dilute HCl or dilute sulfuric acid. Dilute HCl or dilute sulfuric acid gives what in the sense hydrogen gas, gives hydrogen gas. Which metals in the sense reactive metals? Reactive metals in the activity series, the metals which come above hydrogen in the activity series can liberate hydrogen gas with the dilute HCl or dilute sulfuric acid. Okay, so metal means in the activity series above hydrogen. High reactive metals with dilute HCl or dilute sulfuric acid liberates hydrogen gas. For example, zinc we will take, dilute sulfuric acid, what we are getting in the sense zinc sulfate and hydrogen gas. It is a laboratory preparation of hydrogen gas, we can say. Laboratory preparation of hydrogen gas. So zinc metal reacts with the dilute sulfuric acid to give zinc sulfate and hydrogen gas. It is laboratory method. Okay. Now, which metals do not liberate hydrogen gas with the dilute HCl or dilute sulfuric acid? That is Coinage metals, copper, silver, gold, mercury, these are below hydrogen in the activity series. These elements do not react with the dilute HCl or dilute sulfuric acid. These elements cannot liberate hydrogen gas with the dilute acids. Okay, so then next preparation of hydrogen we'll see. We'll take metal. Metal is treated with the base sodium hydroxide. So what we are getting means hydrogen gas we are getting. So which metals on reaction with sodium hydroxide gives hydrogen gas? Metal: beryllium, zinc, aluminum, silicon, tin, lead. These metals with sodium hydroxide on heating gives hydrogen gas. For example, zinc with sodium hydroxide on heating gives sodium zincate, Na2ZnO2 and hydrogen gas. Sodium zincate cation is Na plus, anion is ZnO2 2 minus. Anion is ZnO2 2 minus. Next preparation we'll see. We'll take ionic hydrides. Ionic hydrides. Ionic hydrides means alkali metal hydrides and alkaline earth metal hydrides with water. With water, what we are getting in the sense hydrogen gas. For example, sodium hydride we will take sodium hydride with water. Sodium hydride with water. What happens means we are getting hydrogen gas. How? In the sense Na plus H minus is there. Sodium hydride contains Na plus and H minus. H minus contains one lone pair. The water we will write. Oxygen contains two lone pairs. Now here this it is shifting here. This lone pair attacking this hydrogen. This bond pair is shifting. Therefore, this becomes a hydrogen gas. It is OH minus and Na plus NaOH we will get. So sodium hydride with water we are getting hydrogen gas and sodium hydroxide we can say. Next we will see manufacture of hydrogen gas. Manufacture of hydrogen gas we will see Lane's process. We will see Lane's process. In Lane's process, how to get hydrogen gas we will see. We will take iron, that is hot condition. Iron is present at hot condition. Then we will take steam. We will take steam. Here iron is in hot condition. We are treating this iron with steam. So what we are getting, we will see. This iron is becoming Fe3O4 and we are getting hydrogen gas. So this iron is in hot condition. Over this steam is passed. What we are getting means Fe3O4 and hydrogen gas we are getting. This Fe3O4 again we are converting back into iron by treating with water gas. By treating with water gas. Water gas contains carbon monoxide and hydrogen. In this case, this Fe3O4 reacting with carbon monoxide and becomes Fe, carbon monoxide becomes CO2. This carbon monoxide takes this oxygen and becomes CO2, this ion becomes Fe. Then another reaction, this Fe3O4 reacts with hydrogen gas. Hydrogen takes oxygen and becomes water. Here what is the remaining means ion is remaining. So we are converting Fe3O4 back into ion by water gas. So how to do this method? It is a manufacture of hydrogen gas. It is used for manufacturing hydrogen gas. Manufacturing means industrial scale, large scale preparation. Okay. So we are taking iron in hot condition. We are passing steam. So it is heated. Iron is converting into Fe3O4. Steam is converting into hydrogen gas. After certain time, stop passing steam. Then pass water gas. Convert Fe3O4 into Fe. Then stop passing water gas. Start passing steam. You will get hydrogen gas. So that these two, that means passing steam and passing water gas should be taken place in the regular intervals. First we have to start with the steam. Up to certain time we have to pass steam. Up to that time we will get hydrogen. Then stop passing steam, then start passing water gas. While we will not get hydrogen gas. Okay, water gas you are passing, This water gas converting Fe3O4 into back into Fe. So we will not get at that time hydrogen gas. After some time, after converting Fe3O4 into Fe, start passing steam while you will get a hydrogen gas. So this is the method used for manufacturing hydrogen gas. This method is called a Lane's process. Here Fe3O4 we have used. This Fe3O4 is called mixed oxide. It is called mixed oxide. Why it is called mixed oxide? Because it contains ferrous oxide FeO and ferric oxide Fe2O3. In this mixed oxide, what is there means ferrous oxide FeO is there and ferric oxide Fe2O3 is there. Therefore, it is mixed oxide. This mixed oxide is converting back into Fe by water gas in this reaction cell. We'll go for next manufacturing hydrogen gas. Manufacture of hydrogen gas, next method. We'll take hot coke. We are taking hot coke. We are taking to that what is passed over that. What is passed means steam is passed. Steam is passed over that. What we are getting means we are getting water gas. We are getting water gas. Water gas means carbon monoxide and hydrogen will be there. In the water gas, carbon monoxide and hydrogen will be there. This water gas is mixed with steam and passed over the catalyst. What is the catalyst means Fe2O3 plus Cr2O3 and heated. What happens means here we are getting a carbon dioxide and hydrogen gas. Carbon dioxide and hydrogen gas. This carbon monoxide is converting into carbon dioxide and hydrogen we are getting. Now this on a cooling, carbon dioxide becomes liquid, hydrogen will be in gaseous state only, then we can separate, then we can get hydrogen gas alone from this CO2. Okay, this reaction is called, this process is called coal gasification. Coal gasification we can say. That means this coal or coke is converted into water gas. This water gas, another name is synthesis gas. This another name is syngas. This process is coal gasification. From this water gas, we are getting hydrogen gas by doing in this method. This method is called this step is called water gas shift reaction. This step is called water gas shift reaction. This step is called coal gasification. This step is called coal gasification. This step is called water gas shift reaction. Next step, we will take natural gas. Natural gas mainly contains CH4. Over that steam will be passed. Then we will keep catalyst, nickel, chromium, catalyst, and it is heated. We are getting water gas. This water gas is treated with steam. We are getting a carbon monoxide is converting into CO2. Then we are getting hydrogen gas. Next method we will see. This method, in this method also called oxidation we can say. Why? Because methane is converting into carbon monoxide. Hydrogen is not converting into water. Therefore, it is called partial oxidation. This step is called partial oxidation. Next step, we will take natural gas that mainly contains methane. It is heated strongly. This decomposes to give carbon and hydrogen. So this is natural gas. It is heated strongly. It is decomposing into carbon and hydrogen. This method is called cracking. This method we can call it as a cracking. We can call cell. Next, we will go for electrolysis. By electrolysis process, we can get a hydrogen gas. Sorry. For electrolysis, we are taking the electrolyte. Sorry. For electrolysis, what and all required? That we will see. For electrolysis, what and all required? For electrolysis, This electrolysis process, where and all used? This electrolysis process. Now, you can see that some articles will be coated with gold. Some articles will be coated with gold. Some articles will be coated with copper. Some articles will be coated with silver. That means coating one metal over another metal. That is called electroplating. That method is called electroplating. That is taken by which process? In the sense electrolysis process. And in the metallurgy, extraction of metals, in the metallurgy, that is extraction of metals, this electrolysis process is used for purification of metals. To get pure metal, we will use this electrolysis process. And in the preparation of many substances, electrolysis process will be used. That means alkali metals will take. Alkali metals are quite reactive. That is reacting with the water itself. Alkali metals we cannot expose into atmospheric air because it is quite reactive with atmospheric air. So we cannot prepare alkali metals by chemical method. In the metallurgy, you might have heard that copper metallurgy, extraction of copper from copper pyrites, extraction of iron from hematite ore. That and all by chemical method only, that is manufactured, that is extracted from their ores. But alkali metals, how to extract alkali metals by chemical reaction? They themselves quite reactive. Then how can we prepare alkali metals by chemical method? No, electrolysis method only we can prepare. So electrolysis means what? What is the meaning of electrolysis? That we'll see. How to arrange, what are the things required for going for electrolysis? What is the setup will be there for electrolysis? That we'll see. Now, one vessel will be there like this. This vessel will be called as a electrolytic cell. This we have to call it as electrolytic cell. Then inside this electrolytic cell, some solution we have to take. What is the solution? Suppose aqueous solution. Aqueous solution of sodium chloride, dilute sulfuric acid, aqueous solution of copper sulfate. Like this, some solution will be taken here. This solution is called electrolyte. This we will call it as electrolyte. Sometimes we cannot take aqueous. Why? Suppose in the manufacture of sodium, can we take aqueous solution as electrolyte? No, because sodium is quite reactive with water. Therefore, in that case, molten substance we have to take. Molten in the sense, some solid is melted, we will get a liquid form. That liquid form we have to take here. That is not aqueous solution. Okay, molten in the sense that is not aqueous solution, that is melted form, that is in liquid form, that is melted form, that is in liquid form. Okay, that molten substance we have to take as electrolyte. Then we have to dip what? In the sense electrodes we have to dip. That means some metal rods we are dipping here. Okay, here one metal rod and another metal rod we are dipping here. These two metal rods are called electrodes. These two metal rods are called electrodes. One is cathode, one is anode, like this. Can we say that electrodes always metals? No. Sometimes even non-metal also will act as electrodes. Graphite is a good conductor of electricity. So in many places, graphite is used as a conductor, electrode. Many places we are using graphite as a electrode, we can say. So sometimes even salts we can take as electrodes. Silver chloride salt. Like this salts also we will take electrodes. Okay, sir. Now this we will connect to battery now. We are connecting this to battery. We are connecting this to battery. Okay, we have to pass a DC current. So here minus, here plus. So here, how this process is taking place, that we will see. From this minus means it is called rich of electrons. This electrode is given negative sign. That means this is called rich of electrons. This positive sign means deficiency of electrons. This plate is given positive charge. That means this is a deficiency of electrons. This is a negative plate, rich of electrons. Now what happens? See, from this plate, electrons will go to this electrode. Then electrons will go to electrolyte. Then from electrolyte, electrons will come to electrodes. From electrode, the electrons travel through this wire and reaches this positive plate. Okay, how the current is passing, see. How electrons flow is there, see. Electrons flow and current flow. Direction is different. Okay, electrons flow from negative plate through wire to this electrode to the electrolyte. Then from electrolyte, electrons come to electrode through wire, reaches positive plate. It is called electrons flow. Current flow means positive plate to negative plate. Sir, now we said about this. What are the things required for electrolysis? That arrangement we have given. Next, what is meant by electrolysis? How electrolysis process takes place? That we will see. Now we will take acidified water as electrolyte. We are taking acidified water as electrolyte. Sir, we have taken acidified water as electrolyte. Then platinum electrodes we are taking. It is one platinum electrode. It is another platinum electrode. Platinum electrodes we are taking. Is there any speciality of platinum electrode? Yes. Platinum electrode is having speciality. What is the speciality in the sense? Platinum electrode is inert, noble metal. It will not go for chemical reaction easily. It is almost inert. Therefore, in many electrolysis, the platinum electrodes will be used. Even graphite electrodes will be used in many electrolysis. Why? Because graphite electrode is inert. Sir, so platinum electrode is inert. It will not go for chemical reaction. Okay. This platinum electrode is connected to negative pole of the battery. Another platinum electrode is connected to positive pole of the battery. Okay, negative pole, positive pole. Here what we have taken, electrolyte, acidified water is taken. Okay. Now first what happens means you see that from this negative plate, electron comes through this wire and reaches this platinum electrode. From here it is going for attacking water. It is attacking what? In the sense water. This electron attacks this hydrogen, this bond is shifting like this. So what happens means this hydrogen loses the bond here, takes electron and becomes hydrogen atom. Hydrogen atom combines with another hydrogen atom and becomes hydrogen gas. This becomes what? What is this? This becomes what? OH minus. Okay, this becomes OH minus. Then another water molecule will take this as two lone pairs. Now what this water molecule does in the sense, in this water molecule, this oxygen is donating this electron pair to this platinum by shifting this bond towards itself and shifting this bond towards itself. Now these electrons going to this platinum electrode and travels through this wire and reaches this positive plate. Then what is the remaining here? We'll see oxygen, hydrogen, hydrogen. This hydrogen loses the bond. Therefore, this hydrogen gets a positive charge. H plus is separated. This hydrogen loses the bond. Therefore, it is separated as H plus. This oxygen is having this lone pair and these two bond pairs as lone pair. Therefore, it is having three lone pairs. Therefore, it is oxygen atom. This oxygen atom combines with another oxygen atom and becomes what? In the sense oxygen gas. These are becoming H plus. Okay. Therefore, in this place, what is happening means reduction is taking place, therefore it is called a cathode. This electrode is called cathode. In this electrode, oxidation is taking place, therefore this electrode is called a anode. So at anode, oxidation is possible, at cathode reduction is possible. This process is called electrolysis. At cathode, what gas is liberated means hydrogen gas. At anode, what gas is liberated means oxygen gas is liberated. Okay, so this is called a electrolysis, we can say.